Hello, geometry honors. Today we're going to look at 10.4. We're still exploring circles, and specifically today we'll talk about inscribed angles and also inscribed polygons. So it's kind of an interesting day. So an inscribed angle is when you've got two chords that intersect in a common endpoint, and so that's going to form an angle. And the arc that lies in the interior of an inscribed angle has endpoints on the angle is called an intercepted arc. So let's draw a picture real quick, actually. I think it'll make a lot more sense. So let's draw a circle. And what we're talking about is chords that meet at a common endpoint. So you see that makes an angle. And so this right here from A to B, that's going to be the intercepted arc. Intercepted arc. That's kind of hard to fit in there. And then, yeah, intercepted arc is that arc right there. And yeah, this angle is the inscribed angle. I'm not writing very well today. There we go. Inscribed angle. So we're going to learn some relationships with inscribed angles. It's kind of cool. Theorem 10.7 says the measure of an inscribed angle is half the measure of its intercepted arc. And oddly enough, I don't have like a good proof of this. And yeah, I apologize about it. But visually, I think it kind of jives. It makes sense. You know, if you have the central angle here, if you recall, the measure of a central angle is the same as the arc. So you can see it's significantly, it opens up significantly more than the inscribed angle. And it turns out it's exactly twice as much. It's twice as big as the inscribed angle. So it's pretty cool. Let's put this to use. So find the indicated measure in circle C. So first up, they want us to find the measure of angle D. Well, it goes both directions. So here's the measure of the arc, and it's going to go half as much will be the inscribed angle, so it'll be 50 degrees. Not so bad. And then the measure of arc AD, again, measure, we're talking about angle measures, so AD. And so it's going to be twice as much as the inscribed angle there, so it's 70. Example 2, find the value of X. So same sort of stuff, isn't it? Since the arc's 76, half as much, X is going to be 38. No big deal here, no big deal. And then the arc is going to be twice as much as the inscribed angle, so 56 degrees. So it's not so bad. Pretty simple relationship, even though it may not be as intuitive as some other things. Let's look at theorem 10.8, and this is a little more intuitive. If two inscribed angles of a circle intercept the same arc, so we got an example of this, angle L, angle M. They are intercepting the same arc. Well, guess what is going to have to be true? Then the angles are congruent. So that's handy to know. Example 3, find the measure of arc KN. So KN, it's going to be 104. I'll just write it right there. And they also want us to find the measure of angle KMN. Well, half of 104 is 52. Just write it in there. What do you notice about angle KMN and KLN? Yeah, they're congruent. Voila. The last thing on the front page here, a polygon is an inscribed polygon if all of its vertices lie on a circle. In our previous notes, we talked about if you had 3 points and you could find the center, or, find a spot that's equidistant to each of the 3 points. And that was actually dealing with an inscribed triangle, which is kind of interesting. But yeah, so a polygon is an inscribed polygon if all its vertices lie on a circle. The circle that contains the vertices is a circumscribed circle. So to draw, like if I was say to draw an inscribed pentagon, the way I would go about it is I would draw 5 vertices on the circle and then connect them to make my 5-sided figure. That's the easiest way to do it. And then, like I was talking about in our previous notes, we had like 3 points, and they said find the place that's equidistant between them, and it would have been the center of a circle that contains all those points. We use perpendicular bisectors. But anyway, so there's a triangle that is inscribed. If you do some other geometry, you may see an inscribed circle with a polygon that's circumscribed. So, you can reverse the relationships. Let's flip it over. Theorem 10.9, I really don't want to write very much here because I think the picture does such a good job. So we'll kind of just draw over this real quick. So we've got a circle, and in the circle we've got center at D, and it happens to be a diameter. Well, if you've got that relationship, then if you draw chords chords that make an inscribed angle, and they hit the endpoints of that diameter there, you're going to know something right away about the measure of that inscribed angle. The measure of angle ABC is going to have to be 90 degrees. And that's going to be true if and only if AC is a diameter. This isn't a huge deal here. It's not a huge jump in understanding. Because if it's a diameter, it's a semicircle, it's 180 degrees, and we already learned inscribed angle is half as much. All right, so not a huge deal. Example 4, name 2 pairs of congruent angles in the figure. So, all right, 2 pairs of congruent angles. I'm definitely seeing R and S. Those jump out to me right away because they both have U. They both intercept arc UT. I can see that right away. So yeah, for sure R and S. So I'm going to get rid of the ones that don't have R and S. Okay, so I got rid of those 2 because those didn't say R and S were congruent. I know that to be the case. Oh, okay. So it's kind of one of those things where you look at it one way, you see the young person, you look at it another way, you see the old person. Now I'm looking at it another way, and I'm seeing inscribed arc U and inscribed arc T hitting, intercepting the same arc RS. So that's kind of cool. So we also know those are going to be the same. The other direction. So we've got RS and U and T. Nice. Example 5. Got some words here. Let's read through this. Okay. Graphic design software program was used In a home improvement store to design kitchen cabinets, the designer shows a wall of cabinets with a 90-degree viewing angle at point P. From what other positions would the cabinets fill a 90-degree viewing window? Okay, so this is kind of a weird, interesting idea. Well, what they're trying to get at, I think, is that the fact that if AB is a diameter of a circle, then if point P was anywhere on that circle, you would have a 90-degree angle formed by looking at, point A and point B. So this is just kind of a silly application sort of problem, but basically anywhere on this semicircle would give you a 90-degree view of the countertop. I'm not sure why that's specifically important, but it is what it is. Anywhere on a semicircle. Anywhere on a semicircle, as long as AB is the diameter, is going to give you a 90-degree viewing angle of viewing there. And our last theorem for this lesson talks more about an inscribed shape. And it turns out if you've got a quadrilateral so the way it's presented is a quadrilateral can be inscribed in a circle. They were starting the other direction because this is a biconditional. If and only if its opposite angles are supplementary. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So you can also take it the other way. If you know that the opposite angles of an inscribed figure are supplementary, then it's going to have to be a quadrilateral. So example 6, find the value of each variable. And it does appear that we've got a quadrilateral that is inscribed in this circle. And as soon as we know that, we know some relationships. We know the opposite angles are supplementary. So 60 plus y has to be 180. So y is 120. And opposite angles of 100 and x, same difference. Example 7, doing some of the same relationships here. Find the value of each variable. Again, it's an inscribed quadrilateral. Opposite angles are going to be supplementary. X is 15. Y is equal to 5. Y is equal to 5. So there we have it. So some new relationships here, talking about inscribed angles. Kind of fun. The big thing is inscribed angle is going to be half of the central angle or half of the intercepted arc, which is a fine thing to notice. 70 makes that 35, that relationship. If inscribed angles intercept the same arc, they're going to have to be congruent. And then we got some relationships with inscribed figures as well. So if you'd like to practice more on this, it's page 676, numbers 1 through 39 odd. Thank you for watching.